Okay. So anyway, we are going to start. We are going to start today. We are going to start with very important part. There is a cardinality formula, right? We'll start with cardinality formula. First, I'll explain you what does that mean, right? So we'll start with cardinality. Cardinality formula. Now, what is cardinality formula? Let me just try to tell you, and after that, I'll proceed further for the proof because proof is needed, very important. So, cardinality formula is the formula or a relation related to the number of elements of sets. So, what is that? I'm going to explain. It is a theorem actually, right? In a better way, when we go for mathematics Olympiad, we call it uh, inclusion and exclusion rule. Inclusion and exclusion rule. Inclusion and exclusion rule, we call it in a more general way. But in class 11, we call it cardinality formula. So, what does that mean? For any two sets, preferably non-empty, right? A and B, number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in intersection. So this is the cardinality formula. This is the cardinality formula. And we are going to go for the proof of it. So please note it down first. By the time I'll construct the graph, actually we will be needing a Venn diagram that I'm constructing here so that we can show you exactly what the Venn diagrammatic proof also gives us. So we have got, I think you have written it, right? So now I'm going to name these elements. I'm going to name these elements, the sets actually. As you already know, we have to always talk about the universal set. This is the universal set what you got, right? And then we have to discuss about the other sets. This is the set A, this is the set B, right? So we have this. We have set A, here you can see. This is the universal set boundary. This is the set A, and this is the set B, and this is the common portion which is A intersection B. Now, moment we go for proving this, we'll go for some supposition. First, to see first what I'll write here for proof. Let we'll consider the number of elements in the set A. Say this number be m. There are m number of elements in A. There are say L number of elements in B, and there are K number of elements in the common portion. Now you see these M, L, and K are the number of elements, not the elements. Be very, very precise about this. Now, what I'm going to do, I'm going to write inside this figure these elements. In this figure, I'm going to write those things. Here in this common portion, I have how many elements? K. Do not again be confused. This K is not the element. This is the number of elements in the common portion. Very fine. Now just try to observe. What is the total number of elements in this whole pink color set? It is M. If you observe clearly, this is M. Out of that M elements, you have already considered K elements here. So how many will be left out here? How many will be left out here? Very clearly you can identify that it will be M minus K. In the very similar logic, you can say that L minus K elements will be left out in the green part, right? Other than the common. That means B minus A, right? So now, if you go for the figure, it's a observation, very clear observation that n of A minus B is equal to M minus K, and n of B minus A is equal to L minus K. Very clear observation, right? Very clear observation. Also, if I am talking about A union B, you can observe one more thing very clearly, that it is the union of these three sets. It is the union of these three sets. Where one more thing is observed, that A minus B is having nothing in common with A intersection B. That means this is phi. Similarly, A intersection B intersection B minus A is also phi. Rather, what I can say that all these three sets are having nothing in common. So, in that way, if somebody asks you what is the total number of elements in A union B, it is nothing but the total number of elements in these three sets collectively. Simply, you have to add the number of elements belonging to each of these sets. Till here, I do hope that you are clear. So I give you 5 to 10 seconds to note it down, and please confirm once you finish by raising your hand. Then I'll proceed further. Okay, thank you, Saurabh. Now you see, we'll be just putting the values. What is n of a minus b? We already have got this as m minus k. Common elements already we have considered is k, and then this is l minus k. Now you can cancel out here whatever is having same sign, sorry, opposite sign but equal values. These two k and minus k can be cut. So once we cancel this, what will left out with m plus l minus k. Now you go back to the original values. M was standing for number of elements in n of A, L was standing for number of elements in B, and K was standing for number of elements in A intersection B. And that's it. That's the proof. We have started with n of A union B, and we finished with this particular expressions. So this is what the cardinality formula of sets is. Cardinality formula we call it because this particular formula involves only the cardinal numbers of the sets. So we have to speak little more about that. We'll go to the next board. First, you finish about this. Then please raise the hands to indicate that you have finished. Okay, so now we'll move to the next. We'll move to the next board. So now here what we'll do is say I'll first go for the generalization. We'll take the notes. This formula is not only valid for one, but we can do the same thing for these three. In the same go, I'll show you the derivation also so that afterwards it will not be needed. So for derivation, what we'll do is this. See, already we had been knowing that union of sets is associative. So we have done the association, and then now the first set will name it as D, right? If you would like to write it here, you can write it better. We have denoted A union B by D. So now we'll be using the cardinality formula again, right? The formula which already we got, right? This we have used. Now you go back to the actual statement for D. It was N of A union B. N of C will remain untouched. फिर you have to replace D here. This is A union B intersection C, right? So this is not a very difficult one. So I am not explaining much about this. You can easily understand. There is no doubt about that. Okay. So I'm just going through this, breaking all these things with rules. Here I have to apply the right distributive property. So that leads to conclude A intersection C union B intersection C. Great. So now you see your final touch is coming. N of A, N of B, N of A intersection B, and then N of C, and then this is union. So again, you apply the formula. What formula? N of A intersection C, then N of B intersection C minus N of intersection of this Now you see all the signs are intersection, so it is useless to apply like that associativity or distributivity. These kind of things will not be there. Of course, we can apply it back, right? We can take that C once only. We should not count that C twice. So here, if I open the bracket, what will I get is the required expression, and this will be ultimately what A intersection B intersection C. Now just formalize it so that we can get a memory aid to remember this formula to apply it directly whenever we will be in need in future. Right? That means all the two sets we have written in the second place, then all the third sets will be three sets, not third sets. All the three sets intersection we are writing at the last. I'm going to talk about the memory aid only. So first of all, you please note down these particular explanations, and then we'll be telling you how to remember this. Okay. Once you finish with writing, you please tell me. I'll be explaining the memory aid. Okay. Thank you. So now you see the memory aid. So memory aid is simple. I'm writing it here. First one, right? Then second two, third three, and then four like this. So what does this first one mean? Means when you expand this formula, first you have to write the elements, sum of the individual elements in the sets. That is taking the sets one at a time. Therefore, I have written first one. This is set 1, set 2, that is set A, set B, set C. Then second is 2. Once you writing all these individually, you write two pairs, all possible two pairs. Say here we have taken 3 sets. So all possible pairs means one pair will be AB, other will be BC, third one will be CA. But when you write 2, make sure that you take their intersections as we did here, right? We cannot get more pairs out of this, so these 3 all pairs we have written. And the thing you have to remember is that next for 2, the signs are negative. Signs are negative, right? So first one always positive sign, 2 always negative signs, and again when you take the third, then sign will again change, it will become positive. And this time you have taken the intersection of all the 3. So this intersection will be only 1, because it will be useless to write, like if somebody wants to write also B intersection A intersection C as another, but this is not the another, this is the same one. So only one term will come. Had it been 4 terms, you could have got more number of terms for these 3 collections, right? So this is what is the memory aid. Now we'll be proceeding further. I'm going to the next board. Now some of the notes we'll be writing, right? Some of the notes we can write. Notes. After this, we'll be taking problems. Notes. Notes number 1, right? If A intersection B is phi, that means sets are mutually disjoint, then you will be getting n of A union B equal to simply n of A plus n of B, right? Because n of A intersection B will be 0. Number of elements in this, because this implies what? N of A intersection B contains elements 0. So this is what the answer is. This is note number 1. This is note number 1. Note number 2. Note number 2. N of A union B, if you look at that figure means the figure we used for the cardinality proof. Anyway, I'm going to redraw the figure again so that you can visualize these things here only, so that it will not create problem for understanding. Say here this is one set, and then another set is here. These two are the sets. These two are the sets, right? These two are the sets. What I want to explain here, you see this. This is the set A, this is the set B, this is the common portion. And this whole is the union, a universal set, not union, universal set. Now, this part on which my this red tip is moving, this is A union B. This is already known to you. This is already known to you. But there are some empty spaces. You can see here, these white places are empty. So empty in the sense, I cannot say that there will be no elements. Meaning is that apart from A union B, you may have some elements left out here. Meaning is that universal set, that means this bigger whole white rectangle may contain some elements other than this union. Meaning is that you can have more elements than union B, right? A union B. That means always will be having a very important result, that is A union B elements number will be always less than or equal to U. It is not necessary that it will be equal to U, right? This is one of the very important part. Always you have to remember. Very important part. Always you have to remember. Next, note number 3, which you have to always remember, because some problems will encounter in future, that n of A as well as n of B both are greater than or equal to A union A intersection B. That means intersection will contain elements which are always either less than each of the individual sets, or worst case they will be equal, but they will not be greater than. Right? It is very clear. Common cannot have more elements than the individuals. Right? So these three are the very important notes which we need actually to do the problems. Whenever we do the problems, then we need all these things. I do hope that you have finished with the notes. So I'll be starting with some of the questions. Randomly I'll pick up, because exercise questions you will be able to do very, very clearly, comfortably. So I'll directly jump into the I'll jump into anyway. First, I'll take some easy questions so that it will be easy for you to understand. Right? I'll start with exercise 1.6. So please open exercise 1.6 and then we'll start with the questions. If you're ready, I can start with. Please indicate me. Okay, thank you, Sonam. Now you see, directly I'll start with question number three, because once we finish with question number three, you will be confident to do question number one and two. So I'll start with question number three. Let me read this question first. In a group of 400 people, 250 can speak Hindi and 200 can speak English, right? And you have to find how many people can speak both Hindi and English. Now you see, first I'll just use so the diagrammatic approach, that is a Venn diagrammatic approach. First we'll show that, we'll see the things clearly, and then we'll go for the statements. Right? We'll go for the statement immediately once we finish with this. So this is the figure. This is the figure what we get. Now this is the U, right? This is U. This complete set is U. That is, it is a collection of 400%. Now there is no name given to each of the sets. So what I do, I'll assign the name H for the persons who are speaking Hindi, and those persons who are speaking English, I assign that collection as E. Then we are given some numbers. I have to find how many elements or how many persons are there in the common person, means speaking both. Say I don't know this, so I write this as A. Okay, I write this as A. And then here, speaking Hindi entirely, there are 250 persons. So if there are total 250 persons speaking Hindi, then out of that A has been already included in the common part. So how many will be there speaking only Hindi? It will be 250 minus A. In the similar logic, you can think about English. So how many will be there who speaks only English? That is. So Venn diagram, it is very, very clear. Sum of all these three number inside should be equal to 400. But just now we have explained a note that it may not be equal to U, right? But why it is equal to U here in this case? That is a question to be discussed. I am going to discuss it here, but before that, I'll note it in a formal way. Venn diagram approach I have not taken here to write the question or solve the question. I am doing it theoretically, analytically. Let H be the set of people speaking Hindi, and E be the set of people speaking English. We have got this. Here, just you see, N of H is given to be 250. N of E is given to be 200. We need to find N of H intersection E, which I wrote as A in the Venn diagram. So here also I write as A, right? So now there is a mistake in the question. To be very honest, let me try to tell you, right? The question should have told, or in question it should have been mentioned that these 400 people should be such that each of them will at least read any one of the newspaper. Sorry, at least speak any one of the languages. What I mean to say is that there should not be anything left out here in this part. My question does not imply that, but your answer is according to this particular concept only, that there will be no person out of this 400 who does not speak any one of these languages, right? So because of this, there may be some problem. There may be some problem when you do it in the competitive exams. But of course, you never be uh, like in doubt, because competitive exams they will make it very very clear that you need to consider the whole universal set or only A union B. Here in this question, I definitely point out the mistakes. That is a mistake in the question, right? But still, we ignore that and we are writing. We have, what do we have? N of A union B equal to N of U, right? We'll use this. We'll use this. But here, as I told you, I'll put a question mark because the question doesn't say it like this, right? Statement should have been modified. So accordingly, what I should write if I use the formula, this, and this is equal to 400, and you give the number inside, whatever is known, and then you find what is the value of A. So A will be 450 minus 450. That means out of 400 persons, there are 50 persons who speaks both Hindi as well as English. Right now, going out of the context, one more thing I want to discuss here: that if somebody asks you that find the number of person who is speaking only Hindi, so now Venn diagram says only Hindi is this. So we should write 250 minus A, right? So it is always very good to draw the Venn diagram. So how many person speaks only Hindi? This is 200, right? See, there is a difference between Hindi and only Hindi. Hindi means those persons may be speaking, some of those persons may be speaking English also, but only Hindi is indicating that they do not speak other than Hindi. Okay, so once you finish with, please make sure to inform me. Okay, Swanam. Now you see question number 1 and 2 are very direct in that sense. Here we have to consider the set H and E from our side, and these data what we have created, this we have to generate from our side. But if you look at question number 1 and 2, these are already given. So I left question number 1 and 2 for you. Even now, if I leave all the remaining questions, there will be no problem at all, right? No problem at all. So I'll jump onto the miscellaneous questions and directly question number those last four, 13, 14, 15, 16. So the rest of the problems, I'm very sure that you will be able to do. So I'll go to the miscellaneous. Please open the book. Miscellaneous question number 13 will do first. 13. Right? Question number 13 will do. And here you will find the difference what we actually had been discussing just now. See, I'm reading the question. In a survey of 600 students in a school, 150 were found to be taking tea and 225 were taking coffee. 100 were taking both tea and coffee. Find how many students were not taking tea or coffee. Right? Rather, they are asking students who are taking neither tea nor coffee. So first, again, in a similar way, just let me try to tell you. First, we'll try to just go for the Venn diagram approach, and then we'll analyze it, and then we'll try to make it a statement problem. Anyway, whenever it will be a three sets problem, we'll do it by Venn diagram. It will be more easier. It's a two sets problem, so we are doing it by this Venn diagram. Sorry, with the formula. But before that, we are trying to see it with the help of Venn diagrammatic approach. This is the U, that is the set on which you have conducted the survey, that will contain 600 number of children, and 150 were found to be taking tea, another coffee, right? So we are going to denote the sets by T and C. T for tea and C for coffee. Okay. Now they are giving you data that there are 100 students who are taking both tea and coffee. Now please be sure when you input the numbers, make sure that always you start from the most inner part, that is the most common part. Otherwise, you will commit mistake. Right? Now we'll go for the outer part. This we'll try to fill up. Now for that you see in T how many persons are there? There are 150 persons. So in this whole pink ball completely, there are 150 persons. Out of that 100 were included here only. So if 100 were included, how many will be here? 150 minus 100, that is 50, right? And then other one is containing 225. So 225 minus 100 is giving you 125. Actually, this problem is so small that you have finished orally. You have finished orally. Now, if somebody asks you any question related to it, you can answer it. But again, I would like to suggest you that we will not go for this. It is just a hint where you will try to solve this problem if these will come in MCQs, competitive exams, right? So here, how we proceed? Actually, you need to find now what you know in the figure, the numbers which are kept here in this outside space. Okay? Okay. Let me write in formally. Let T and C be the sets of people taking tea and coffee respectively, right? According to question what they have given, number of persons taking tea is 150. Number of persons taking, do not write A, I have written this as T. Sorry. Number of persons taking tea is 150. Coffee is 225. And number of persons taking tea, this is tea, and coffee is 100. You need to find what number? You need to find number of elements taking neither of the item, what it is. Now you see how we find. Now we have to find taking neither, right? Taking neither means A union B is the set which says that at least one. Remember it. It is a language equivalent. A union B means at least one of A or B. But I need neither. So it is the complement of this. Now just you see whether you can understand or not. If it is the complement, so I can write it is n of u minus n of A union B, right? Because total is the universal set, totality. So complement will be what? Total number of elements in the universal set minus this set, right? So how much is here? It is 600, and this, acha, again I am telling you, I made a mistake here. Not a mistake, now you can change the set. Anyway, actually I by mistake wrote A and B. It should have been what? T and C. Anyway, I'll modify this. Let it be like this only. Then n of T union C complement will be equal to, directly you can write 600 minus n of T union C, right? So now you can finish it. And the calculation is left for you. You do the calculation and please revert back to me immediately, telling me the answer. Telling me the answer. I'm waiting, please. And you will tell me also whether it is clear to you or not. And if you have any doubt, you will please let me know. Any doubt is there, Swarnav? Answer is 325. It's very correct. Just you tell if you have any doubt so far. Otherwise, I'll proceed. You unmute yourself and tell me.
No doubt, sir.
No doubt. Okay. Thank you so much. I'll go for the next now. Next means I'll not do question number 14. It is very much same as question number 13. I'll pick question number 15. I'll pick question number 15. This is also important. Here I'll not use the formula approach. I'll use the Venn diagram approach. I'll in fact explain you the formula approach also, but that is little not difficult, but like critical type. You have to remember the formula. If you can remember it well, then very fine. Otherwise, it is better to do by Venn diagrammatic approach. So I'm taking the advantage of Venn diagrammatic approach at the beginning, right? So here, what is the question you see first? In a survey of 60 people, that means this time total number of count is 60. Universal set contains 60 people. It was found that 25 people read newspaper each. Okay, they have named the newspaper as each. There are 25 persons to read this. 26 persons read newspaper T and remaining 26 newspaper I. And data also says that 9 persons are reading both H and I. That means out of those 60 persons, you will find 9 persons such that they are reading both H and I, 11 are reading both H and T, and 8 are reading both T and I. And moreover, there will be 3 persons who reads all the 3. Now, on this basis, you have to answer the following 2 questions. So before we go for answering any questions, let me just first try to draw the diagram first and then try to explore what exactly they are saying. So here we'll first draw the diagram. So for drawing the diagram, this time it should be a little bigger because there will be 3 sets. This is the universal sets, right? Now we'll be in giving input of 3 sets here. 3 sets we need. So 3 sets when you draw in this position. It will be better to like make an overlap because you should have a uh, system or you should have a provision that all can be made something among all there can be made something common, right? So we have drawn the 3 sets like this. So these 3 sets will draw it in such a way that you can see there is something common, right? So I'm highlighting this. This part is the most common part. These are the commons of two sets, and these are not common to any one of them, right? So this is what we have started with. This is what we have started with for the figure. Now, before we proceed, let us name this and then we'll try to discuss how to proceed. So, universal set is U. We have named it as U. Then this set I would like to name as set H, depending on what? The name of the newspaper. Then there is a newspaper called T. This is T. And the blue one I would like to name it as I. This is the set I, right? The people who are reading the newspaper I. On that only we have named it. Fine. Now, just before we proceed again to start level, you just see this white box is telling you the 60%. All the 60% are here inside. Out of that, some are belonging to these shaded portions, some may be belonging to these white ones. So now we have to accordingly make the figure comfortable. Here I'll not write the numbers directly. I'll give you 2 approaches. This particular approach, what I'm doing, is for that particular part where you will do it in the description, right? When the question is asked in the conventional exam. Question number 16 I'll do just to give you the approach which you can do for your MCQ type questions. So both the approaches I am saying here the descriptive, elaborative, so that if 6 marks will be there, you will get 6 marks for this. You have to write statements. So in this case, how we will name it? See, always as I told you, you should numbering or you should start naming the elements from the most common part. Remember it. So most common part is A. These common parts I want to write as B. Here suppose there are C elements. Sorry, in between my laptop was just going out of battery. Okay, so this is C. Then here I'll consider that there are D number of elements. Then here I can consider E number of elements. Then here I'll consider F number of elements, and here Z number of elements, and here outside it is say H number of elements. So we have noted it like this. Please draw the figure roughly. I give you 5 seconds to 10 seconds to complete the figure, and just immediately let me know once you finish it. Okay, now we'll make it more elaborative and we'll just write it, right? So first of all, we'll use a very important statement. With, sorry, this ink will not be visible. With given informations, we constructed the Venn diagram aside where H is the set of all people reading newspaper H. I'm writing NP for newspaper. Then T is the set of all people reading newspaper T, and I is the set of all people reading newspaper I. So this is what we did, right? Also, after that you have marked it, that also you have to write. Also, we mark the Venn diagram with suitable letters to indicate the number of elements, right? So that is ABC I'm talking about. So once we did this particular description, now we'll be proceeding for indicating those numbers from the most innermost part. Remember it clearly. Most innermost is A. So what will be A containing? A is the set. I should not write it extensively. If you want, you can write here the description that it is the set of all elements, or it is the set containing all persons reading all the three newspapers. I'm just going to write the numbers. So how many persons were reading three newspapers? Three. So you see, readily you got the value of A. Then you come out and you talk about two at a time, not three at a time, two at a time, right? Two at a time. That means also we have the number of elements in say two. First, you consider about reading newspaper H and I. How many are reading newspaper H and I? It is H intersection I. That is 9. Okay, very fine. Now from the figure H intersection I, right? H intersection I will be which portion? H intersection I will be this portion, right? That means A and D, both the elements are there. Together they are those persons who are reading both newspaper H and I. So number of elements in A H intersection I will be A plus D, and that is equal to 9. So now already you know what is A. So can you tell what is the value of D? It will be 6. So you have found D. This is over. Then you go for the another two, that is H intersection T. H intersection T, that are 11 elements in number. Okay. What is H intersection T? H intersection T means this is A plus B, right? So now you write the elements A plus B. It is A plus B equal to 11. Now already you know A equal to 3. So what will be B equals 8. So you get the value of the another letter. Now the third one is there. What is left out for the third one? It is T and I. T intersection I is equal to 8. So T intersection 8 is containing, you can look at the figure, it is A plus C. A plus C is equal to 8. So what is C containing? C containing, sorry, value of C is what? 5. So you see, already you have done with many of the values. Please note it down, and once you finish it, please raise the hand. Okay. Now once you have finished with two sets, now you come to the individual, right? So suppose n of h. N of each, if you look at the figure, what is the sum? It is A plus B plus E plus D. And N of each is given to be, that is number of persons reading newspaper, each is given to be 25. Value of A is how much? Rather, if you use a idea, instead of writing A and B separately, A plus B is already here, you see. So directly you write this as 11. And then value of E you have to find. D value is obtained, it is how much? It is 6. So now from here, can you find what is E? It will be 25 minus 17. That gives you 8. So very precisely, E equal to 8. Right? Very precisely, E equal to 8. Right? Now, rest of the part I'm going to explain, because I'll not go for the next page to draw it again. I'll explain you. You will be able to do it very, very clearly. I have little space here to do it, but I'll not do. You listen to me and then you try to do. Next, once you finish with H, you try to do N of T. That you do N of T will be what? It is A plus B plus C, A plus B plus C plus F. You have to find F from here. Then N of I, if you do, it will be what? A plus C plus Z plus D. You have to find Z from here. So once you find all the letters, maybe not H right at this moment, afterwards, once you find the remaining letters inside this figure, you are 90% done for the conventional problem approach, right? So now, once you get this, you now read the question, what they are asking you to do. First question is the number of people who read at least one of the newspapers. Number of persons who reads at least one of the newspaper. So it means they are asking you about the union. If you remember in the last question, I told you that at least is standing for union. So they are asking for N of A H union T union I. N of H union T union I. So now you might be thinking, okay, sir has given me very extensive way, because in this way, if you find, you have to add all these letters inside, whose values already we have got here. But in the other hand, you have already a formula of N of is union T union I. Fine. In this particular case, you have, so you apply directly, right? But you see the second part. What is the second part of the answer? It is given that number of people who read exactly one newspaper. Number of people who read exactly one newspaper. So exactly one, here it is. Exactly one, here it is. Exactly one, here it is, right? These three are the persons, E, F, and G. These not three persons, sorry. These are the number of persons who read exactly one newspaper. E number of persons reads each, F number of persons reads T, and Z number of persons reads I. So if somebody asks you how many reads exactly one newspaper, so you have to add E, F, and Z. Those values are already here. You will find it. Right? Now you see, I can add up more questions. Listen to me. Somebody might ask tomorrow that how many persons are there who reads exactly two newspapers? Exactly two. Remember it, not three. So exactly two, how many will be reading? B, they are reading exactly H and T. Then C, exactly reading T and I. D, exactly reading H and I. So total these things to be added to get the number of persons reading exactly two newspapers. Right? Some more modifications can be done. I can ask you, tell me the number of persons who are reading exactly H and I but not T. Then I have to talk about this number D. So this can be a varied question here in this particular bigger question. So please note it down. And if you are finished, again, as I told you, indicate me. I'll go for a next question. That is question number 16, where I'll show you the approach directly, where we can directly solve it without writing extensive statements. This is the approach what we have to adopt when we are going for a question containing 6 marks or 4 marks. Otherwise, you will not get marks if you do not explain it like this. Okay, so now I'll go to the next board. Now I'll be picking the question number 16, and here absolutely I'll use no such calculations. Directly we'll be doing the problem by inserting the number here itself. So you see this approach also, because this is going to help you immensely in doing the problem in a short span of time. This is one of the set. Already I know that there are 3 sets, so immediately I have drawn even before reading the question. So anyway, by the time, please go on reading the question yourself. So we have got this, and this is the universal set U. Now you see, we'll be putting the entries directly. There are 3 products, right? Once I'll read it again, even if you have read. In a survey, it was found that 21 people like product A, 26 like product B, and 29 like product C. 14 people like product A and B, 12 liked products A and C, and 14 liked B and C. 8 liked all the 3 products. How many like product C only? So for that approach, we have to now first fix the sets. So this is A, suppose. Then this set is B, liking the product B, and third one is the set C. Right? So we have named it. Now, as I told you, you have to always go on marking this from the most inner core. So we have to start with most common part. So how many like product? All the 3, 8%. See, earlier there's a difference. Earlier when we did, we have started marking A, B, C, but this time we are not marking A, B, C. Rather, we are marking what? We are marking the numbers directly. This is the approach which you have to use when you do it, or your MCQ type questions, because the answer will be very clear here itself. Okay, very nice. 8 we got. Now, next you see start coming out of two sets together. A and B. How many persons are liking product A and B? Just identify 14 persons like product A and B. 14. That means this structure is containing total 14. So if 8 is here, how many will be left out? Those 6 will be left out here, right? So this particular portions will contain how many? 6 persons. So here we'll write 6, right? This is a 6 person. Similarly, now you come to the part B and C. B and C, product B and C is liked by 14 people. Out of that, 8 are here outside. Outside means liking all the three products, right? So it will be 6. Have you understood? And then you go for now A and C. 12 people like product A and C. Out of that, 8 are already there inside. So this will be containing 4. Am I clear so far, son of? If you have any question, you can raise. Otherwise, I'll proceed further. You can unmute and you can say me if you have any question. Please.
Question, sir.
No questions. Clear?
Yes.
Okay. So now you see, now we'll be coming to individual sets. This is the set A. In this set A, I should have the number of persons belonging to those category who likes the product A only. So how many persons like product A? This is 21. So in this particular oval, I should get total count as 21. Out of that, if you see, there are some counts here already. So you have to fill up this in such a way that total count becomes 21. So just count how many are here. It is 4 plus 6, 10, 10 plus 8, 18. So left out 3 will be counted here. It will be 3 here. Now for B, you go for B, there are 26 persons. So out of 26 persons, 20 are here. 8 plus 6 plus 6, 20 will be there. So this remaining 6 will be here. And similarly for 6, you identify. It will be 29 here. So out of which you have 18 here. So 11 will be left out. And more importantly, outside how many will be left out? So that will be simply what? Sum of all these. Sum of all these, right? Sum of all these, is there any total number mentioned? No. Here there is no total number mentioned, so it is now not possible for us to write the elements or the persons who is here. That means liking no product at all. It will be possible if somebody tells you that total among these persons who have conducted the survey. So now you start answering what they are asking. What they are asking? Find the number of persons liking product C only. So figure says that there are only 11 persons liking C only. Now you see, I have to again add separately. When you do this problem in the competitive exams, obviously you will keep the target in your mind. In that case, these numbers, what we have found, are absolutely useless. After finding these numbers, After finding these numbers, you directly find these numbers. Do not waste time in finding this. Right? So that of course will work on time when you do the problem from your side during the exam. So now here, if I add one more question from my side only, the number of persons liking A and C, but not B. A and C will be liked but not B. So A and C will be liked by 4% but not by B. That means only these 4 will be coming as the answers. Right? So somebody might ask, like, uh, only C and only B. Only C and only B. Total number of persons liking only C and only B. So what will be? Only C there are 11 and only B there are 6. So total answer will be how much? 70. Right? So be very, very careful about these particular statements. We can give you more number of problems in these particular questions. We have lot of scope because set theory is a first area. So today I did not finish the whole exercise. One more sitting will be needing for finishing your set theory questions, including all extra problems, right? So today I'll be signing off. Before that, if you have any question, you can ask. Otherwise, you indicate me. I'll go off. Okay, Swarnav. Then see you on the next day. Bye bye. Bye bye.